What's up, everybody? Just wanted to go live again. Part two, day four. Um, had nothing much to do this evening, so I just wanted to just jump right back in. But just to give it more velocity and volume, and more weight. Um, Moving forward, I have a lot more. I feel like going on. If you need any websites, let me know. I build websites. I'm a web developer. I'm building in public. Uh, if you need any websites for your business or for any projects you got going on, let me know. And right now, I'm just building live. I'm building web application, website apps, and mobile apps. So I'm learning how to build mobile applications and SaaS-based platforms, software as a service, and whatnot. Um, so I'm going to be on for a little while tonight. Um, uh, Moving forward, I might just keep it 2 parts every day, like a two hit KO, kind of like a chess move. Um, but the main point is that focus, right? So I'm putting 8 hours a day. I'm going to try to put 8 hours a day live, um, almost like a full-time work. Now I can do it 9 to 5. That would be interesting, right? A full 9 to 5. I could try. But actually, it might be easier to ask Google what the best bet is. Do I do it in one hit, or do I just separate it? Because I'm thinking that 9 to 5 time slot might be prime, might be a prime time slot that I'll. It's an opportunity, actually. It's an opportunity cost that I don't want to, you know. It's yeah. I mean, I'll still take breaks, of course. Like I'll take lunch breaks. But 9 to 5 sounds like it's like it's a good option. I see it. Some people think it might not. I mean, the mental reset is just, I don't know. But 9 to 5 learning. Spent my 9 to 5 learning for 2 months. A brand new platform is something new. I guess something different, and I think it's an opportunity. My biggest opportunity is time right now. I have a lot of time, and I don't want to waste it. Just not even waste the opportunity. It's just But if I have to take care of stuff during the day, I don't know. Let me see, but I'm about to start. Something new here. Anyway, guys, I believe in the work. I think it's a good idea. Um, for now, I'm gonna go for it and see what happens. Right? There's nothing bad that can happen for it if I just keep taking breaks, take care of myself. Um, I think that's the only viable option moving forward. Just all that, one big time, like one time block for the day, 400 days. And we'll see. Hmm. Let's see. Let's get some studying done, shall we?
To Bubble. If you have an idea for a web app that you would like to build and you don't know how to begin, you're in the right place. Throughout this course, we'll guide you step by step on how to use the Bubble editor, the Bubble platform, and how to build your next web app with Bubble. By the end, you'll have all the tools necessary to build something new, realize your vision, or even jumpstart your own business. Let's begin. Before we jump into building our first app in Bubble, let's familiarize ourselves with the key concepts that will be present in every app we create on the platform. Our Bubble journey begins in the Design tab on the index page, also known as your app's homepage. There are several types of elements that we use to design our app, but let's start with visual elements. Visual elements include text, buttons, icons, images, and anything else that is primarily useful for visual design. These elements make up most of the interactive triggers that your users will click on. Next, we have container elements, which allow you to organize the visual elements and any other elements in groups, repeating groups, pop-ups, floating groups, and group focus elements. Each of these container elements can show data from your app's database and serve a critical role in your app's design. In addition, each container element has its own container layout that defines how the elements it contains are positioned for responsive design. Then we have input forms, which allow you to create forms that capture information from your users. You build these forms using inputs, multi-line inputs, checkboxes, drop-downs, search boxes, radio buttons, picture uploader, and more. Input forms are the primary way in which your app will accept user-submitted data that you can save and modify later. Finally, we have reusable elements, which allow you to design something once and reuse it across multiple pages. Reusable elements come with their own design workspace independent of the page, so you can drag any visual, container, or input into a reusable element, then drag the reusable on the page as if it were any other element. Because it's reusable, when you make a change to it, those changes will reflect everywhere you've added the reusable element in your app. When you're ready to see the elements you've added to the page, you preview in what is called Run Mode. This is how we view what your app looks like to the public and test how it functions when your users are interacting with it. The Bubble platform gives your app its own domain name, which you can use to build your app on the free plan until you're ready to upgrade and deploy your app with its own custom domain. To recap, the Design tab is where you add elements to the page that make up your app's design. Once you've designed these elements to your liking, you preview your hard work in Run Mode. Next, let's learn all about the Property Editor. Whenever you add an element to the page in the Design tab, a floating window accompanies it. This floating window is the Property Editor, and it's one of the most important windows in Bubble. Let's take a look. As it's named, it allows us to edit the properties of whatever we have selected. The Property Editor comes with 3 tabs: Appearance, Layout, and Conditional. The Appearance tab lets us control the look of the element and define the contents of the element. For instance, here we have the Property Editor opened for this button, and on its Appearance tab, we have a text area for defining what text should appear on it. Generally, elements will come with a predefined style. We'll learn more about styles in the next lesson, but for now, let's just click Remove Style so we can see the different style settings for this element. With the style removed, we are now directly customizing the overall look of this element, from many font properties to its color and even its borders. Next, we have the Layout tab. In this tab, you define the element's size and position on the page for responsive design. As you'll start to see, elements gain alignment controls through the parent container element they are in. This tab gives us granular control over every element, so we'll talk a lot more about the Layout tab throughout this course as we build. Finally, we have the Conditional tab, which allows you to define conditional statements for the element and manipulate its properties depending on if the condition is true. This is extremely powerful. We can change the look, the visibility, the text we display, or any of the available properties for this element. To write a conditional statement, we are given a dropdown that has other data sources from our app and the page. We'll talk more about these concepts soon, but for now, to understand how we write conditionals, think of it like a question that you ask yourself. For example, what property do we want to change on this element when the current user is logged in? Let's say we want to change this button's text to display something different. We'll select the text property and rewrite the text we want to appear on the button. When the user who runs the page meets this condition's criteria, the element will display the properties that we conditionally changed. If we had another condition saying the same thing, the bottommost condition will be prioritized, so Bubble will evaluate conditions from top to bottom. To recap, the Property Editor is one of the most important windows in Bubble because it controls the individual properties of what you have selected. Alright, next let's learn all about styles. When you drag an element on the page, you may have noticed a default style was applied. Each new application you start comes with preset styles like this for every element. The style saves the visual look of the element and allows you to name it so you can create a style guide for your app. If you remove the style from an element, whatever style was applied will now be directly editable on the element instead. As your app becomes more complex, you'll find that updating each individual element's style manually is not scalable. On top of that, it hurts your app's performance. For consistency, speed, and efficiency purposes, you'll want to create styles for all of your elements once and reuse them across any elements that should have the same appearance. To create a style, you can do so directly in the Style dropdown. Whatever design properties we had on the element will apply to this newly created style. To change these properties for this style, click Edit Style, which brings us to the style in the Styles tab. The Styles tab lets you view every style that you've created, and editing a style in the Styles tab is very similar to the Design tab. You're given a property editor with the same 3 tabs, so you can edit all the styling properties right here. Styles allow you to save the properties from each of these 3 tabs, like the font, the padding, and any condition that would relate to how the element looks. Once you design your page, almost all of your elements should have their own style. Styles aren't the only thing we can reuse. In the Styles tab, we have style variables. These variables allow you to set global properties for your app's font and colors, which you can then save and reuse on elements directly or in styles. Here we can set the app font, so every element with text that uses the app font will use this font family by default. So if a text element style used the app font, we can now change the app font and the style will update its app font as well. Same goes for color. We have numerous amounts of color variables that we can define, like the primary color for your app's brand, the primary color for text within elements, the primary text color, background color, etc. These color variables can be used wherever you assign a color hex value, so you can do this directly on the element. However, styles can use these variables to their advantage as well. So if your style is using a color variable, and we make a change to the color, all of the styles that are using this color will update automatically, making it incredibly easy to change the colors on a large scale. We briefly learned about conditions in the Design tab when we discussed the Property Editor. Here in the Styles tab, we can create conditions the same way, but only for style-related changes. The conditions we write here are saved to the style, so any element that uses this style now automatically comes with this style conditional. Note that the conditionals we write inside a style will be overwritten if we add the same conditional directly in the property editor of the element. If you wanted to see what the element will look like when the condition is true, you can toggle this off-on button to view a preview. In addition, when a condition affects the style of an element, you have the option to add transitions. Transitions allow you to animate the before and after state of the element when a condition occurs. For example, when a button using this style is hovered, we change the background color. Without a transition, this change will happen abruptly. But with a background color transition, it will smoothly animate to its new color. We can also customize the duration and the ease of the animation curve right next to the transition. We can even set a style to be the default, which means it'll be applied automatically anytime that element type is dragged on the page. Now that we've covered elements, the property editor, and styles, we're going to learn about responsive design. Responsive design is when the elements on your page adapt for any screen size. By default, we are building our apps for desktop, but as the page width shrinks for tablet and mobile, we can fully control how our elements will be displayed. To build a responsive page, our page must use a responsive container layout. There are 3 responsive container layouts that dictate how your elements are positioned. They are aligned to parent, row, and column, and each of them differ where elements are placed. Column will vertically stack elements on top of one another, row will horizontally place elements next to one another, and aligned to parent will cut the container into 9 positions based on its width and height to place elements in. Each of these layouts behave differently as the page shrinks for smaller screen sizes. Contents within columns will stay the same. Contents within rows will wrap to the next row. And contents within aligned to parent will overlap. Therefore, it's recommended that your pages in Bubble have a column container layout, and the groups you place on the page will have their own container layout. In doing so, your page will be comprised of group elements that are a mix between column, row, and aligned to parent. Let's take a look at an example. Here, our page container layout is a column. Each of these sections of our page is put into its own group element. And since a group is a container element, we define its container layout individually. If we look at this page in the responsive tab, we can see as the page gets smaller, all of the elements start shrinking and their container layouts respond accordingly. The responsive tab allows us to preview what our app will look like for any screen size by using this ruler to see the width we're targeting. There are even presets for desktop, tablet, and mobile views, so we can easily see what those would look like. As we drag the ruler to the right, the page grows and all of the elements will hit their max width, or if no max width is set, they'll continue infinitely with the parent container. The key to understanding responsive design in Bubble is by understanding min and max width. Every element, including containers, have a min and max width. The min width allows us to define how small an element can shrink, and the max width defines how large an element can grow. For most needs, elements can comfortably use a min width of 0 pixels, so as the page shrinks, the elements will shrink along with it regardless of how small it gets. If a min width is set and it happens to be a size that is greater than the screen size you want to target, the element will stop shrinking wherever its min width is set. For example, if this group has a min width of 320 pixels, but the element can shrink to 0 pixels, the group will stop shrinking when the page hits 320 pixels, meaning the element will never be able to reach 0 pixels. Keep this in mind as you build, and make sure your elements have appropriate min widths. We can't add any elements to the page in the responsive tab, but we can edit any of the responsive properties. If things start feeling misaligned as the screen size shrinks, you can control this alignment conditionally using current page's width and manipulate the properties of the container element at any screen size. So if we wanted this alignment to change when we hit a mobile width, that condition will activate automatically when the page hits that screen size. You can also control the element's margin, padding, and any other responsive properties, allowing you to get extremely granular control with your responsive designs. It's important to note that if your page is set to a fixed layout, it will always stay fixed at whatever width and height is set, so it won't be responsive, and the ruler in the responsive tab won't work. Same thing goes for fixed width and height. To make it responsive, be sure to uncheck any fixed properties. This is a primer on responsive design. For more on the subject, check out Bubble Academy. Now that we have a full picture on designing and styling in Bubble, we're going to learn how we program in Bubble using workflows. Bubble is built around a workflow-based programming system using events and actions. A workflow is the event that runs a series of actions when triggered. For instance, when a user clicks on a button, the event, something will happen, the series of actions. Each page has their own workflow tab where workflows are created and modified. So if we're on the index page, the workflows that we'll see here are only for this page. To create your first workflow, you start by picking the event that you want to trigger. Most of the time, it will be when an element is clicked. You can also start a workflow from an element in the Design tab. In this button's property editor, we can see in the Appearance tab the ability to start and edit the workflow attached to it. Whenever we start a workflow from the Design tab like this, the element is clicked event will automatically set up for us with this element already selected. Now that we have the event defined, we need to add some actions so when the event triggers, something will happen. Click here to add an action, and the action window appears. This window shows you all of the relevant actions that are provided to your app, and each action is organized into categories depending on what they do. Anything related to users can be found under Account. Data can be found under Data, so on and so forth. For our first workflow, why don't we navigate the user to another page in our app? For example, under Navigation, we can find the Go to Page action, and if we don't already have another page created, we can create one directly from the action. Some actions like this one will allow you to remain in the Workflow tab while creating things elsewhere in your app. Now when we preview this in run mode and click the button, the workflow triggers and we are taken to the next page. If the workflow should only run under specific circumstances, you can add a condition, like you would to an element in the Design tab. You can either add conditions to the event or to specific actions. When you combine events, actions, and conditions, you are programming, but with a workflow-based system. If you need to insert an action before another, clicking on the arrow will reveal the action menu and you'll be able to add an action before the current one. Subsequently, you can drag and drop actions to move them from step to step, or right-click for more control. Those are the very basics of how to set up workflows in Bubble. We'll be doing much more of this throughout the Getting Started course, so be sure to stick around for later sections. Next, we're going to learn all about creating our first user. Having users is a core need for many apps, so every Bubble app comes with the concept of a user. No need to build a complicated authentication sign-up login flow because Bubble makes it super easy. Users can sign up, log in, log out, and users can create accounts for others. This is all made possible because of the built-in user data type, which can be found in the Data tab. This data type comes with built-in fields unique to users. The most important one is the email field, which stores the email address that the user signed up with. To capture users, we first need to create a form that collects their email and password. Back on our index page, I'll go ahead and create a header and our sign-up form. For the input elements, we'll set their content format to be email and password respectively. This will format the user inputted text to expect email addresses, as well as when a user types in their password, hide the characters that they type. Finally, we'll start a workflow on our sign up button, and in step 1, add an action under account, sign the user up. We're going to match the dynamic values of the input to the action's requirements. Here the action requires an email, so we'll find our input email element from the list and select its value. Next, we'll do the same for our password. After the sign up action, Bubble will recommend the next step you take is to send the user an email. Usually this might be a welcome email that you would send welcoming the user to your app. Of course, you can take other actions, such as resetting the relevant inputs of the sign-up form so the values the user submitted are reset, or more commonly, send the user to another page once they're logged in. Now that this workflow is set up, let's test this in run mode and sign up a user. Once we hit our submit button, the form resets and the user should be signed up to our app. To confirm this, let's head back to the Data tab and navigate to the App Data subtab. App Data gives us a database view of all of the user-submitted entries for that data type. Currently, we only have the built-in user data type, where we'll see the entry for the user that's signed up. Now that our app has its first user, we can build our page design around it using a data source called current user. Current user represents the current user using the app. It can be found anywhere you add dynamic data. Here we have a reusable element that contains our header that lives on all of our app's pages. Inside, we have a typical setup with buttons for sign up and login that we only want to show when the current user is logged out. With current user as a data source, we can write a conditional that controls the visibility. Likewise, when the current user is logged in, we can show the logout button. We can also use current user to find any fields from the user data type, like we do here displaying the current user's email. We'll talk more about dynamic data soon, but for now, current user is a main data source that you will use in elements like this and in actions. Now if we preview, we can see our app is telling us who the current user is. Current user is made possible because of the built-in user data type. All of our app's users are handled there, but the typical actions to sign the user up and log them in are not the only ones at our disposal. There are other ways to interact with the user data type. First, instead of logging in with a password, you can instead send an email to your user with a magic login link. If you do, every time your user wants to log in, the magic login link will email the user with a unique link that they can use once to log into your app. And second, you can also easily set up social login with Google, Twitter, Facebook, or any other platform that provides it through our plugin ecosystem, just as I'm sure you've seen on countless of other web apps. Regardless of how you sign the user up, they will all be stored as a user in your user database. And unlike other databases, since the user type is built in, you may have noticed that the user database allows you to run as any user. This is excellent for testing your app in case a user of yours encounters a bug or needs your help. You can authenticate as them to see what they see. This is also a key way to make sure your users have the right privacy permissions for your app, but more on that later. Now that we've learned about the built-in user data type, in the next lesson, we're going to make our own data type and start to see how we can customize our app to whatever idea we have. Data types are the most high-level concept you define when you build a data-driven application. You can think of them like a kind of thing that you want to have data about in the database. Or, to phrase it as a question to ask yourself, what do you want this app to do? Later in this course, we'll be making a project management app that allows users to create teams, projects, and tasks, all of which are data types that we must create. But before we do that, let's demonstrate creating a data type with a simple example like a comment upvoting system. This means we'll need to create a new custom data type named comment and add custom fields to define what each comment consists of. Fields are your ability to define additional information to store on a data type. When creating a field, it must be explicitly defined as one of the field types like text, number, dates, yes, no, file, image, or even a custom data type. For our comment data type, we'll want to add fields for the contents of the comment as text and votes as number. When thinking of the fields your data type will need, think about your app idea and what you want to achieve with it. For example, if we want our users to have profile pictures, we can add a new custom field called profile picture that is type image. Every data type comes with built-in fields for created by, modified date, and created date, which are automatically attributed when a user creates or modifies a thing of that data type. We'll talk more about things next. We can leverage these built-in fields to display the creator of the comment if they were signed in when they created it, and we can display this user's profile picture next to the comment. With our data types and fields set up, we can design a form so users can write their comments. Rather than dissecting this form now, we're going to highlight what this does and explain more about it in the subsequent lessons, so keep watching. But know that we have a simple form for writing comments, a workflow that submits the new comment, a repeating group for displaying the comments, and an icon for upvoting our favorite comments. We can create, read, update, and delete comments because it's a data type. And we can do things with comments like upvote them and attribute them to the user who wrote them because we can leverage other data types like the user and the custom fields that we add to them. In the next few lessons, we're going to do more with this example while we learn more key concepts. Let's talk about the word thing. In the Bubble language, thing refers to an entry in your app's database. For example, this comment is a thing, and it has a unique ID representing it, as do all of these things in this database. You may be familiar with the word object or row from other platforms or traditional programming languages, but in Bubble, they mean the same as thing. We refer to things when we want the user to do basic CRUD actions. CRUD is an acronym for create, read, update, and delete. And in Bubble, we have actions in our workflows for performing these operations on a thing. First, we have a create new thing action. This action creates a new thing in the application database for that data type. For the type in this action's property editor, select an existing data type from the dropdown or define a new one right within this event by selecting create a new type. With our comment example, we have a workflow when a user clicks on the right comment button to create a new comment. But just creating the thing isn't all that our example does. We also want to store the contents of the comment and the amount of votes. So in the create new thing action, when you click set another field, we can find all of the fields on the comment data type and set them equal to any value. In this case, we set it equal to match the inputs value. When this workflow runs, a new comment thing will be created into our app data for the comments data type. And if a user was logged in, the thing will be automatically attributed to that user. Again, thing relates to each of these that we store here for every data type. You can also create a thing directly from app data. This is extremely useful for testing as you build if you don't yet have a front-end form that creates a thing with the workflow. Whichever data type you have selected, you'll be prompted to define its fields and then hit create. However, when you create something like this, you can't attribute it to a user, and the thing will instead be attributed to app admin, so use this as needed. Bubble's workflow actions will also allow us to make changes to a thing. Let's say we wanted to allow users to upvote comments. Well, using the make changes to a thing action modifies an existing thing in the application database. If we want the users to be able to upvote comments, we could add an upvote icon that can access the comment and use the make changes to a thing action like so. When this icon is clicked, we run the make changes to a thing action and update the upvote field for that thing. The action has context of the thing we want to modify, so we can access the thing's fields. In this case, we can select this comment's votes and add to it, making our expression state that when a user clicks like, votes equals this comment's votes plus 1. Or in other words, whatever the vote count already is, add 1 to it. If we preview this, each time we click on the icon, we can see the workflow run and the number change, as the workflow has updated this thing's upvote number. We can also make changes to a list of things, as it's common you'll want to edit multiple things at once. This action is equivalent to make changes to a thing, but modifies more than one entry. To do so, we must provide the list of things to change property with a list of each thing that we want to modify, and then select the field we want to change. In this example, we would first have to retrieve a list of comments to properly set this up. And of course, we can delete things from the database with the delete thing action, or we can use the delete a list of things action. The concept of thing is key to understanding the Bubble language because it's how users interact with our app's database. Now that we've learned about thing, we're going to learn about dynamic data. Most information that you will use in your Bubble application will be dynamic and usually coming from your app's database, but it can also come from other sources of data, such as external APIs or plugins. In all of these cases, you will use the expression composer to define an expression that will be displayed as an expression in the editor and evaluated in run mode. For instance, you will see in the editor current user's email, which in run mode, depending on who is logged in, will display the logged in user's email. The expression composer is a key element of the Bubble editor that lets you build these expressions without typing anything, but instead by picking options in the drop-down menu. The system will automatically prompt you in the next menu with options that are available given what you have selected so far. For instance, if the first main entry in the expression is current user, the next menu will offer options such as is logged in, is logged out, email, profile picture, etc. In Bubble vocabulary, the main entry, or the first choice in a dynamic expression, is known as a data source, and all the chunks after it are known as operators, like the email field, or any of the expressions like first or contains. The composer lets you build complex expressions by combining different sources of data and different operators. Expression types are evaluated in the editor to validate the type consistency. For instance, if you're trying to display the current user's email in a text element, current user won't be valid, as it evaluates as user, not text, while current user's email will be valid because it is text. Whatever the final operator of a dynamic expression is, must evaluate to the intended type of content. Bubble has two ways for helping you catch issues and bugs. In the editor, we have the issue checker, which will alert you to any missing property or inconsistency. When an expression isn't valid, it will be reported as an issue in the issue checker, and the whole expression will be displayed in red. Then in run mode, the debugger is useful to understand how an expression is evaluated by inspecting the element itself. We'll talk more about the issue checker and debugger in more detail later. Now every time you see dynamic data in an element or workflow, you should keep in mind which is the data source, which are the operators, and how the whole expression is evaluating. Next, we're going to learn more about type of content and data sources. We've talked about the building blocks of responsive design, user registration, data types, dynamic data, and things. Now we're going to dive into the next level of building your UI by exploring type of content and data sources. Container elements can explicitly declare a type of content and data source. Type of content allows you to define the type of thing a container displays. and the data source property lets you select what the displayed thing or list of things is. This is how we're able to build complex UIs that display the data from our database and allow for our users to interact with that data. For this to work, the value of the data source must match the type of content. Let's look at an example. Here's a common scenario where we have a group that has a type of content for the data type user and the data source as current user. The group contains visual elements that display the user's fields, such as the user's name and the user's profile picture. All child elements that are contained within can access the fields from the data type that it expects, and the data it returns will be the data from the data source given. In other words, these child elements are accessing the data from their parent group's type of content. If we preview the page as a logged-in user, we can see that the current user is passed into this group as a data source, and the text element retrieves that information and evaluates the fields as directly as it would even if it weren't retrieved from the parent group. However, once the type of content is set, the data source can pull from anywhere so long as it evaluates to match the type of content. For example, if you had another group that also pulls the user, and you wanted this to read from that group, you can call out that group's type of content, and read from that data source, and use it for this group. This is how you can really start to get creative with building your UI. Another container that can accept a type of content is the page. A common example would be if we created a profile page and set the type of content to user. Now whenever we try navigating to that page, we must pass in a user as data. Note that the page itself doesn't have a data source property, but will instead pass this data in the URL. So in our earlier example, where we retrieve the current user, we can start a workflow that when we click this element, take us to the profile page, and pass in that user. Our action will have context with the elements on the page that it can reference, so we can pull the user from any data source. And in the case of the current user, we can also just reference current user. When we run this workflow, we are now going to that user's profile page since that's the user that is passed in. And pages set up this way now have access to a new data source called current pages thing, or in this case, current page user, which gives us access to the user that we passed in the URL. This lets us easily build a profile page tailored to the current page user whose profile we're on. In groups, pop-ups, floating groups, and group-focused container elements, the data source must evaluate to a single thing, like this. But for repeating groups, it must evaluate to a list of things to display. Since the majority of container elements evaluate to a single thing, it's important to make sure you are retrieving the right thing. Fortunately, the issue checker will let you know if the data source and the type of content don't match, so you can fix it. Another important concept is that the type of content has to be defined, but the data source can change. For additional flexibility, you can control the data source in the Conditions tab of the container. You can also leave the data source blank and have it populate from a triggered workflow. This is extraordinarily powerful because it's useful to leave the data source blank and change it when something triggers. Keep in mind that changes made by actions this way will override whatever you specify as the data source directly on the element or as a conditional state until you run a reset action, which will then restore the data source to its original setting. Now that we have deeper familiarity with type of content and data sources, we're going to learn about repeating groups. Up until now, we've only displayed a single thing from the database in container elements. And while displaying a single thing is great for certain needs, there are times when you would want to display a list of things. And to do this, we use a repeating group. A repeating group displays lists of things, either coming from your app data or from APIs. When you add a repeating group element to the page, Bubble wants to make sure you set it up correctly, so it will warn you that you must have a type of content set. Once the type of content is defined, the repeating group needs a data source that evaluates to be a list of things matching the type of content. For example, this repeating group is set to display comments, so we retrieve a list of comments from the comments app data. To search your app's database, we use the do a search for expression, which will search your application's database based on what type of content you're searching for. As long as the repeating group's data source returns a list, you can pull the list from anywhere, like from an external API, or even a field that is a list on a data type. But for this example, we are just pulling all of the comments in our comments database. Once this is set up, we can focus on how to design the repeating group by drawing our elements into the first cell and only the first cell. The way it works is whatever is in the first cell, the remaining cells will follow. Each cell represents one thing from our list. To display our comments, we'll insert dynamic data and see a new data source available called current cells thing. In the case of our comment example, current cells thing becomes current cells comment. And when we select it, we can display the comments fields from the comment data type. For this text element, we'll set the text to current cells comments content. So when we preview, we see every comment in the list from our data source. Behind the scenes, our repeating group repeats the contents of the first cell for each item in the list and displays each unique thing. Whenever we customize the appearance of the repeating group, we are usually controlling the cell itself. For example, when we change the container layout of a repeating group, we are defining the container layout for each cell. We can of course group elements within the cell using other container layouts for custom designs, but the parent cell's container layout is defined here. By default, we have rows and columns of the repeating group as fixed values. So that's how many rows and columns will fit into this repeating group's overall width and height. If we uncheck fixed rows and columns, we have control over the min height of the row and min width of the column, so we can control how many cells are displayed given the size of the repeating group. Control like this allows us to create flexible list layouts. By unchecking fixed, we've also revealed more properties at our disposal, which will allow us to design interesting looking lists for our app. For example, we can control the scroll direction, or if we didn't want it to scroll, we can have this repeating group show everything in the list immediately. In our example, we are currently retrieving a list of every comment, as we haven't constrained the search otherwise. But if we only wanted to retrieve comments for a particular thing, like a post, we need to narrow our search. To do this, I've gone ahead and in our data tab added a new data type called post that comes with its own fields. And on the comments data type, added a field that is post. This allows us to create a relationship between comments and posts, and later in this section, we'll learn all about connecting data types. I've also moved our repeating group to a page that has a type of content as post. Connecting the types like this is key because as your app grows, you'll need granular control over what you want the user to see. So it allows us to constrain searches like this, where we search for comments where the post equals the current page's post. We can also sort the results of the search by descending order, so the most recent comments show up top. Now if we preview this, we aren't seeing every comment in our database, only the ones that relate to the post we're viewing. Repeating groups are the way to display lists of data, and with some design, you can customize it to look like a list of cards, a table, or whatever your app requires. Now that we've seen how it all interacts, we need to make sure only the users with the right permissions have access. To do this, we're going to create our first privacy rule. By default, your data is not secured until you set privacy rules. All data created by your users or yourself can be read by anyone. This is appropriate for things such as comments on a blog, where you'd want to share it with the world. However, many apps involve users submitting information that you don't want to share with the world, such as their names and emails, or comments meant only for people they already know. Anyone with some programming skills can view all of your app's data, even if there isn't a page in your app that explicitly shows the data to users. You might be thinking, so how do I secure my app? Well, this is where privacy rules come into play. You can find privacy rules in the Data tab under the sub-tab Privacy. With the right privacy rule in place, they guarantee data is only shown to users who meet the expected criteria, and because privacy rules are enforced on the server, it makes them secure. Let's take a look at an example privacy rule with our post data type. There are two parts to a privacy rule: the condition that must be met and the permissions that are allowed if that condition is met. We write privacy rules like we do other conditions, like on elements or in workflows, but we are only given access to two data sources, one for the data type and one for the current user. We use these data sources to make conditional statements. Since we are on the post data type, let's limit visibility to only the creator. The easiest way to think about how to write a privacy rule is to use a statement like, I want users to access these permissions when this post's creator is current user. Using this post, we gain access to the post data type's fields, such as its creator. And by comparing it to whoever is the current user, we are now checking to see if it's a match. And if that's true, then that user has access to whatever permissions we check. For instance, let's allow that user to view all the fields on the post data type, find their posts and searches, and any attached files. Now we've defined what the user who meets this criteria can do, but you might be wondering, if they don't meet the criteria, what permissions do those users have? Each privacy rule comes with the permissions for everyone else panel. Think of these like the default permissions for the users who don't meet any of the above rules. In this example, if you aren't the creator of the post, let's uncheck every permission from everything else, so only the creator of the post has permission. If we preview a repeating group searching for all posts, half of our posts won't show because we aren't logged in as the user who created them. We can only see the posts that we've made. When you're first building, privacy rules are often a cause for why things are not appearing. For example, if we allow everyone else to find posts and searches, and allow for the post created by field to be visible, we will now see everyone else's entries. However, we won't see the actual contents of them since that field was not checked. And in fact, if we inspected this element, we can see that certain fields are being hidden due to privacy rules. We recommend that as you get more familiar with Bubble and creating data types, you set up privacy rules sooner rather than later, because it's all too common to forget to add them or force you to rethink your data structure later to incorporate them. It's also easy to forget to add a permission that should be checked, and oftentimes you may be left confused wondering why something isn't displaying, and the answer is usually to check privacy rules. Privacy rules are additive, so if a user meets multiple conditions, they are granted access to all of the permissions combined. It's key that your app has privacy rules so you can control who can view what, and none of your data is left unintentionally exposed. For more info on privacy rules, be sure to check out our in-depth tutorial. Next, we're going to learn about connecting data types. How should I structure my database is a common and important question. Luckily, your Bubble database is quite flexible and there are many right answers. It's also easy to fix later on if you realize you've made a wrong turn. There isn't one catch-all for how you should structure your data because it's essential to structure your data in a way that can scale with your specific app. In the Data tab, we have the Data Type subtab, where as we previously learned, define what we want this app to do. When you define a new field on a data type, you can specify what type of field it is, which means it can even be another data type. This is how we connect types. You may be familiar with terms like one-to-one, one-to-many, or many-to-many when connecting types together. In Bubble, you don't explicitly declare relationships like this, but you can still easily achieve the same end results. This means you don't have to tell Bubble which specific field is the unique ID for the related thing, because it will connect the whole thing regardless. When you specify another data type as a field, you're creating a relationship from this data type to that one. You may already be familiar with this type of relationship from our earlier comments and post example, where our comment data type has a field for a post, allowing us to search for all the comments for that post. This is one of the most important relationships to understand when you're first starting out. This relationship allows a single comment to be related to a single post. So when we search for comments, we constrain the list the search gives us to only look for comments that are for this post. The post field would be defined when we create a new comment, and the post field gets its value from the current page post that we're viewing. You can also link this field directly in app data using the primary field for a thing. For example, here we have this post, and here we have this comment. We link the two together by connecting their unique IDs. If we edit this comment, we can see our field for post. If we know the post's unique ID, which is not something you can easily remember, we could type it in. But if you are going to be testing your app frequently this way, you may want to change the primary field so you can search based on something more human-readable like the post title. Then when you type in the title, you can connect the appropriate post. You can set primary fields for every data type here in app data. You can also make any field a list of that specific type. Therefore, you can specify whether a field should relate to just one thing of that linked data type or to a list of things under that data type. This means that instead of searching for comments where the post equals the current page post, we can just use the current page post's list of comments. Now that you know you can either reference a single data type or a list of data types, it is up to you with how you want to structure your database for your app. But as a rule of thumb, if your app will need to store more than 100 things on a list, then you should make it its own data type and do a search for it rather than have it as a list on a field. The more things the lists have, the slower your app will perform. However, for smaller list of things, a list field will be faster than doing a search. So it comes down to knowing your app's needs. And the best way to figure that out is to ask yourself, will more than 100 users need to create this thing? Or in the context of our example, is it possible that we'll want to store 1,000 comments on a post? If so, structure appropriately. With the right data relationships, your options for building things become infinitely easier throughout your app. And there's more ways that you can connect your data types together, but focus on these two for now and make sure you understand the difference. That's the basics of connecting data types. Next, let's look at parent-child hierarchies. Understanding the relationship between elements and their parent container is key to developing a deeper understanding for building in Bubble. Styling your app to look like your intended design is easy to do by matching properties. It's when your design and data needs get more complex that understanding the hierarchy of how we build is key. The top-level parent element is the page. It defines the container layout that the page uses for all of its immediate child elements, and it can have a type of content defined. As you build, you inevitably structure your pages with container elements, and mostly with group elements, which can set their own type of content, data source, and container layout. For example, if we add a group to this page, we can already see the parent's container layout, the page, affect this group's position, which we can control in the group's property editor, where we have position controls based on the parent's container layout that is set. To keep going, this group can have its own container layout, and if we add elements to it, it becomes the parent with its own controls, and any child element it has inherits its position controls, so on and so forth. This is the responsive design hierarchy. As we've seen, if we set a type of content for this group, the child elements it contains will have access to the parent group's things fields. And this relationship can keep going no matter how many nested levels deep you want or need to go. This is the data hierarchy for your design. These two hierarchies are key to call out as you think about how to build the UI for your app. Let's take a look at a typical page and see them in action. Here the page is a column, and on the page we have a group that is row. No type of content or data is set so far. This row holds two groups where one is dedicated for a sidebar and is a column. The other is dedicated for content and is also a column. So already we have page, column, main group, row, two groups that are both columns. We'll add some more groups to the content section, and these groups will have their type of content and data source defined. Their child elements will then pull from their parent group's type of content. We even have a group that has a type of content and data source, and then an inner group that is mimicking its parent group's type of content and data source, just so its child elements can have access to both. Passing data this way is called inheritance. This inner group is inheriting its parent group's info. But inheritance isn't the only thing to call out when working with the data hierarchy. This group over here is referencing a group from all the way over here, which, as we just learned, is the one inheriting its parent's data. So the ability to reference data is not only just from the direct parent, but any container on the page can reference any other container so long as it matches the type of content. As you continue to grow your skills when building your app, remember how these hierarchies work as you plan out your design with Bubble in mind. Alright, next let's learn more about reusable elements. Reusable elements allow you to design something once and reuse it across multiple pages. They come with their own design workspace independent of the page. After you finish designing your reusable element, you can then navigate to any page's design workspace and drag the reusable element onto the canvas. Reusable elements are really useful for grouping certain functionalities that should exist on every page together. For example, if you want a header that triggers a sign-up pop-up, you should build it as reusable. As much as you can, build with reusable elements in mind, as it will make the editor lighter and make your app easier to maintain. Plus, it's a good way to create reusable workflows, as each reusable element has its own independent workflow tab. You can even add reusable elements inside other reusables to stay organized. Each reusable can set the type of content inside the reusable workspace. Then each reusable instance on each page will have a place to set the default data source of that particular instance to match the type of content. You can also use the display data actions to change this data source, as well as show and hide actions just as you would with any element. For those looking to build single-page applications, consider adding every view as a reusable element, and hide and show it conditionally on one page of your app. There are many use cases for reusable elements, so be sure to start adding them to your app sooner rather than later. Since Bubble is very open-ended, you can and probably will make some mistakes as you design. A mistake can be as simple as a missing field or an issue with an inconsistent type. Whatever it is, the issue checker will check your app in real time and notify you a list of issues to fix. The second you get an issue, you'll notice a red warning icon in the top bar, and clicking on this warning icon will reveal the issue it's flagging. Clicking on each issue will take you right to where the issue is happening and highlight it so you can fix it. It is very important to keep the issue list as short as possible at all times, preferably to 0, as issues can make your app non-functional in run mode, and Bubble won't let you deploy to the live user-facing version of your app if you have any outstanding issues. So the issue checker covers your mistakes in editor, but for mistakes in run mode, you rely on the debugger. When your application doesn't have the expected behavior in run mode, the best way to analyze and fix the issue is to get into each workflow action one by one to see where the wrong data is being computed or where a condition is evaluated in the wrong way. That's what the debugger is for. It allows you to run workflows at different speeds, normal, slow, or step-by-step. The normal mode runs workflows without interruption. In slow mode, there's a 1-second pause between each action and the next, and in step-by-step mode, you control the execution of the workflow. This is the mode you'll use most often. When more than one workflow is being executed, each of them will run one after another, and all will follow the same execution mode in the debugger. Be sure to check out our tutorial on how to use the debugger for more information. Finally, you can also use the debugger to inspect elements on the page. Sometimes you need to figure out why an element is displayed in a particular way, especially if you're using conditions or displaying some data. The Inspect dropdown lets you pick an element on the page and see the list of conditions and fields and their values in the current situation. When the inspector is on, the debugger will expand and you'll be able to pick the element you want to inspect. You pick an element to inspect either by clicking on it, which won't trigger any workflows attached to it, or by finding it in the drop-down menu. This is especially useful to inspect an element that is visible or understand why the element isn't visible. Once an element is selected, you'll see on the right the different properties and conditions and how they're evaluated. You'll also be able to see at the bottom of the inspector a list of any other values the elements have in their context. When a value is blue, it's a dynamic expression, and clicking on it lets you evaluate it piece by piece. If you're using conditions, the debugger will show you in green the conditions that are evaluated to yes, and in red those that aren't. Again, clicking on the expression will let you evaluate it piece by piece. The debugger is also useful for debugging privacy rules. Privacy rules can lead to complex situations to debug, as it can hide fields from a thing. When you click in the evaluator on a thing that has been hidden due to privacy rules, a red mention will be shown explaining what's being hidden. With both of these tools at your disposal, you'll be able to catch issues and debug workflows easily. Next, let's talk about the difference between live versus dev. When you're building your Bubble app, you're using the development version or environment of your app. This is done on purpose so you can test what your app would look like and how it functions. When you deploy, your users use the live environment. By default, your Bubble app has two different versions called Dev and Live, and they both have separate databases containing your app's database. All of our data that we've added to our app database thus far has been in our development version database. To view live data, you can also shortcut this and change from Dev to Live in the App Data tab. You may have also noticed that when you preview your app in development, your URL will have version test next to it, which means it's using the Dev database and logic. Users on your live app will be using the live database, so their URL will not have version test attached to it and instead use your app's domain. By default, app data will show you all of the things for that data type, but you can also create new views to filter the data your users submit so you don't see every field. You can even constrain the view to filter results. Whenever you create a new view in development, it will create the same view in live, which helps you filter your live app data by those constraints. As the app admin, you can create, modify, delete specific things, or do bulk uploads and exports from the Data tab, and you can do this for both live and dev. As your app grows, you can upgrade your plan and add more environments to your app besides dev and live for even greater collaboration and flexibility. A pillar of Bubble is the community that supports it, and one way of supporting the community is by having a plugin ecosystem. The Plugins tab extends the functionality of Bubble by installing and configuring plugins. Plugins add additional elements, events, actions, and data sources to your app. These plugins are created by the Bubble team and other Bubble users, and therefore are available as both free and paid. Some examples include external services like payment providers such as Stripe, analytics providers such as Mixpanel and Google Analytics, and social networks such as Facebook are packaged as plugins, as well as some other elements like draggable elements, multi-select, mouse and keyboard interactions, and one of the most frequently used plugins, Bubble's API connector. All of these plugins are here to help enhance the default capabilities of Bubble, so it's key that you rely on them from time to time to help build your specific app. Now that we've covered the key concepts, it's time to build your first app. In the next section of this course, we're going to be building this project management app that allows users to sign up, create a team, add collaborators, and more. As you build along, you'll see all of the key concepts discussed throughout this section, and by the end, you'll have a completed app that you can build upon.
All right. That was a good run. What I want to do next actually revolves around why I went live again. But looking at the time, it's an hour in. And I know I have something going on tomorrow. So the plan for tomorrow is the same thing, basically. I'm gonna just get on live and basically not worry about the live stream, but focus more on just the learning piece of it, the actual day, instead of just the hours that I'm putting into it. So it gives me a different vantage point. But that's all I'm gonna say about it. I'm just gonna focus on learning and using the platform more and more. But that's it. Not worried about anything else right now. And like I said, if you need a website done, let me know. I'm available. And for one, I'm gonna focus on the design fundamentals. There's a 20-minute mobile quick start. I might do that. I might get a quick start on mobile in 20 minutes. That would be awesome. And also design fundamentals. So both of those I want to get to. I want to do the design fundamentals and then get like um, a couple pages at the way, like, practicing cloning some pages. Because he's actually teaching design, and part of it is like um, I'm learning more, like, you know, um, so I'm learning more, like, here I'm learning, like, okay, so it looks like I'm learning both sides of it, like, so landing page and app design. So it should be fun. This one's 2 hours long. Um, Learn modern UI design best practices. Of course, I'm gonna try to build as I go. And to do something real quick, let me try some building. Let's see. Let me try something live. So what I'm gonna do, try and rebuild ChatGPT if I can flex that muscle right now before I get into the design fundamentals. Because I got like a couple hours left. I wanted to do 4 hours live, to be honest. I ended up thinking I was gonna do like an hour. That's kind of bad because I kind of can't be seen on camera too. But um, let me see. But if I try to focus on tomorrow, then I'll be able to just, and it'll be a good project for Monday. I think calling ChatGPT, that will be fun. So I'll focus on that for tomorrow. So I'm gonna get a good night's sleep, replenish, and catch myself tomorrow. Not like anybody was here, but I'm just keeping track of my thoughts and stuff. So yeah, I'm actually happy and glad I went live again. But that's for another day. I think it was kind of maybe, well, going live for twice in a row should have been um, should have been more prepared, but it's okay. So I'm gonna clone ChatGPT tomorrow. Should be a fun project for all day tomorrow, so I can work on design. Ah, actually, let's do a little fun little something. Uh, let's actually just forget it. I was gonna show you guys. I was gonna start up school. That's the thing I was looking into. And so what this is, it feels like I'm elevating. I went from watching entrepreneurship videos on YouTube to now looking at Y Combinator, is a website for a course. So they have a course, and I want to take it before it goes down. Right? So I'm signing up for. Oops. Looks like everything's. Oh, never mind. It's working. So I guess this is okay. It's not. What am I actively? No, I'm just learning. Hmm, got it. Okay. Oh, this looks good.
Hey everyone, I'm Harj Tagger, one of the group partners at Y Combinator. Today I'm going to talk about whether you should start a startup. Because YC invests in startups so early, I've spent a lot of time with people who aren't yet sure if they should start a company or not. I've helped many people, including my own.
This is okay, but not what I'm trying to do right now. Okay, so far, so good. I guess I waited till like it was a little late in the day, but let me just do this real quick. Oh, nah, I'm okay. Let me see. I could start every day with a little bit of, you know, motivation, but it's like a whole different course, it seems. So, but every day I could do this. Every day I could just watch this a video. And that's about it. Taking this a little seriously, which is good. So I like this. I like this a lot. This is what I've been looking for a little while. So on and so forth. I like the co-founder matching, so I'll be doing that. Awesome. Just to keep me motivated. what I'll do. All right. And I'll be structuring my days, kind of like it's a show, I guess. So let's go back to here. Let's do that. That's about it for me now today, guys. It was a good turnaround. I could try to go a little bit longer, but I'm gonna focus on my 9 to 5 tomorrow, so it should be fun. But yeah.